we actually learned how to examine correlation between a quantitative and a qualitative variable. I wonder if you remember that. When we do two independent sample Ttest or NOVA, right, there is a group variable and there is a quantitative measurement variable. That's kind of studying correlation between a quantitative and qualitative, right? And last hour we do chi-square test, that is correlation between two categorical variables. Now, if you have two quantitative variables, right, that's where this Pearsons correlation comes in and linear regression comes in, right? If you have two quantitative variables, how do we study the significance of correlation between the two quantitative variables, right? So what I use is actually the example. The two measurement, handgun registration, the number of people got killed by handgun or got injured by handgun. And so these are all pairs of quantitative number. We want to see whether, number of handgun registration and number of people got killed, there's a correlation or not. Right? So for this pair of number, I call this number of handgun registered X and number of people got killed Y. So I can plot these data. I think in the first assignment you did the scatter plot, right? So you can plot all these ordered pairs and get a scatter plot there, right? And the scatter plot showing you that when number of handgun registered increase, number of people killed by handgun increase. So there is a clear trend there, right? And this trend looked like a straight line pattern, linear pattern. We call it linear trend, okay? So when we do studying the correlation between two quantitative variables, usually we like to do this scatter plot and see whether there is a clear trend. This trend doesn't have to be linear, okay? But linear is the most simple trend, though, okay? And there is a statistic that helps us to measure this linear trend. It's called correlation. And the correlation is based on the concept of averaging the standardized score of X and Y, right? So for all these ordered pairs, if you can standardize them, find a standard score of this and this, and find a product of all those and take average of those. That's the idea of correlation, right? And there's so-called a Pearsons sample correlation. Pretty much doing that, right? For each pair of X and Y, you standardize X using the value of X, standardize Y using the value of Y, and find a product. Do that for each pairs and add them together and take average. Now again, we take average not by dividing n, by dividing n minus 1 because that's the degrees of freedom we have. And this quantity is called Pearsons sample correlation. Okay, so it's based on the product of standardized score. When averaging the product of standardized score. Okay, because of standardizing, so this quantity, regardless of what sample you use, this quantity always stay between -1 and +1 for all kinds of data you can come up with, right? So how actually this is kind of an example. I have these X and Y's. I find out their mean and standard deviation. So I standardize X using the mean of X and standard deviation X. Standard Y using mean of Y and standard deviation Y, and find a product of them and put it in here. So I do that for all the pairs and add them together. I get like 12.24, and I divide it by, I think I have 14 pieces, so divide by 13, I get this number. This is called Pearsons correlation, 0.94. Right? That's pretty high Pearsons correlation. So this is called sample Pearsons correlation, right? This measurement has this property. It's always a number between -1 and +1. It shows the strength and the direction of straight line linear relation between the two variables. Right? Can this number be 1? Well, probably, right? Only happen when all the data points lie on the straight line. Then this R can be 1 or -1. Okay. And rho, of course, is a Greek letter. We use that to know the population correlation, right? We never know that, right? But this is just simple to denote that if there's a population correlation. Okay. Of course, what we show here is actually the formula for calculating it, right? And there are different ways to do it. There are shortcut formula for it, right? For you, I guess, most of you use the R commander, right? So life is easy, okay? But hopefully you understand how we get that, okay? And so let's say you're able to use the software to do it. Now, if you look at this graph, which one shows a more stronger linear trend? This one, right? So you have a number that shows much stronger linear trend. If you look at the chart at the distance, it forms very close to a straight line figure, all right? So when you have a situation like that, your R score are much more closer to a 1 or -1. Right? Of course, this is 1 because the trend is positive. When one goes up, the other also goes up, right? That's a positive trend, so you get +1. Now, this is a graph actually showing 4 possible situations. This is a situation that you have positive trend, so the R will be closer to 1, right? This is a negative trend, and it's very much a straight line. Your R will be closer to -1. When you have a situation like this, your Pearson's correlation, well, the direction is hard to find, right? So the correlation probably very close to 0. Could be negative, could be positive, but very close to 0. You have this one that has a very close trend, right? It's a very clear curve, right? So there's a trend. One actually definitely affecting the other. However, this is not a straight line pattern. So when you calculate R, this R could be also very close to 0. That's why, when you're trying to study a correlation between two quantitative variables, first thing you should do is draw a graph. Don't just compute the Pearson's correlation and draw your conclusion. Okay? It is possible that you see that there's no strong correlation, the R is very close to 0, but there's really a strong trend, but you didn't visualize that, you didn't understand that. Okay? So you must try that, right, before you actually try to conclude your analysis. Okay? Yes?
This is Abby from Akron.
Yes.
Is there a video somewhere to guide us in how to put all of that information into Excel for the Pearson sample?
Yeah. Yes. I think so. Right. This is.
I was looking and I can't find it.
Okay. I will show you. I will show you how to do that. Right. Later on today in the class. Right. In a minute. Okay. So. Anyway, so. When you see a trend, right, sometimes your trend look like this, and statistically, there's really no significant pattern there, no trend there. But if you want to do statistical testing on this trend, on this correlation, there's a T-test for it. There's a T-test for correlation, right? This is kind of a general test. You can test for the correlation equal to a specific number or not, okay? And the behavior of this statistic R, Pearson's correlation, is very similar to the mean, right? So its test is almost like a test for mean. It's a t-distribution, right? So we standardize its Pearson's correlation by subtracting its mean. Under null hypothesis, the mean of the sample correlation is actually the correlation of population. Under null hypothesis, rho 0 divided by standard error. So this is actually that t statistic for testing whether your correlation equal to the p0 or not, right? I guess if once you learn the t-test for mean, this is similar, except for the degrees of freedom. In this case, it's n-2, right? Different from the t-test for mean because it involves actually estimation of 2 parameters, so you lose 2 degrees of freedom. And after that, the t-test is a t-test. You find the t-score, you find the tail area, multiply by 2, that will be the two-sided test p-value, right? So it's the same thing, okay? So it shouldn't be too hard to do. And of course, the test that are most commonly used is testing whether there's a 0 correlation or not, right? If correlation is not 0, that means there's correlation, okay? So this is often we do. Testing for rho 0 equal to 0 or not. Okay, so that formula can be simplified to this. But anyway, you will use a software. So our software will actually compute this and give you the p-value. So if you actually want to carry out the test, that's use R times square root of n-2 divided by 1 minus R squared. That's what you saw in the formula, right? You get a 9.65. And this is, you want to use a t-distribution with degrees of n-2 to figure out the p-value for it. Okay. So I guess up to this point, if you know what's going on, the rest of them is the same. You should know how to do it, okay? And if you use a software will give you a p-value. That's even better, okay? And so you can use this test to test for 0 correlation just to conclude whether there is some correlation between two variables or not. But again, I have to tell you, correlation does not imply causation, right? So you have to be careful. We see correlation doesn't mean one affected causes the other, right? So unless you collect the data from a properly designed experiment through randomization and so forth, okay? So observational study, you definitely don't want to draw this kind of conclusion, right? Don't. And also, the test we just talked about is a parametric test, right? So if your data is not bivariate normal, then you probably want to try a non-parametric test. So there's a non-parametric test called Spearman's rank correlation test, okay? What's the difference between this one and the Pearson's correlation is that you just rank all the data and apply the Pearson's correlation coefficient formula to the ranks, And that's Pearsons correlation. Okay? So that's nothing new, right? It's exactly the same formula except for applying to the rings. Okay? Here, this is just a shortcut formula. If you can find a difference of the ring for each pairs of data, use that instead of using such a complicated formula. Right? That'll save you some trouble, right, if you want to do it by hand. And so you can test with zero correlation using the Spearman's test. And this is a test statistic. This is the Spearman's correlation coefficient. Sample size, you know, that's square root of the. So it's exactly the same as the formula for Pearson's correlation test. Okay? And it's a t-test with degrees of freedom n minus 2. So how do you do that? Actually, this is what I just said. You know, you have the handgun registration, the number of people got killed. For handgun registration, rank them from smallest to largest. For number of people got killed, rank them too. Right? So instead of using the original data, use a rank to calculate the Pearson's correlation. You get the Spearman's correlation. Okay? And you can use a shortcut. This is a shortcut formula to do it. Right? You get the Spearman's correlation as 0.874. A little bit smaller than Pearson's correlation. Pearson's correlation is 0.94. This is 0.78. Okay? And then you run the same test. You get the p-value. You can conclude the analysis. All right? So that's how you do the test. It's if we have the software, it's very easy. Okay. This is actually the output from software from SPSS. In fact, right? You get the p-value. You also get the test. I mean, it's actual correlation and p-value. Okay. This is for Spearman's. Okay. This node actually here is for Pearson's, and p-value all very small. Okay, so p-value small means you're going to reject the null hypothesis. All right, so the correlation is significantly different from 0. Okay. So if you want to do it with the R, you would have to create the data, those two columns. Right? Let me see. If I can do this quicker by, let me show you, PC, okay, PC. I have the data there. Actually, we can go to get the data for our, there are several places we can get data. If you are in my web page, you click data directory, there is a place like 1_MPH, right? If you click on that, there's a list of data that I kind of use in this class. There's a data, I think there's a data, REG killed, okay? If you, you can download that, oh, I'm using the wrong, I think my Explorer won't let me download it. Will it let me download it? No, it doesn't let me download it. So I have to use a different browser. I don't like that. Okay, Firefox. But go to my website, click on data directory, right? That's one place to go. Or if you go to our course page, it's in week 10, right? There's that link to G-chain. Oh, people. Okay, data directory, 1_MPH. Go down to red kill, right click, save that. It's an SPSS file. Okay, so I click that and put it in download folder. I'm going to open my, okay, this rkill.save. When you see a file with extension .save, that's an SPSS file. Okay, so you click on R, go to R Commander. Want to import that SPSS file, click data, import data, and SPSS data set. And I'm going to call this REG1, okay? So click OK, and look at the data. Where is download, right? Download, in the download folder. I just downloaded the download folder. You probably have it in a different place. So view the data, that's the data there. Okay, that's the data set. So that's how you prepare your data. Remember, these data comes in pairs. I think the reason you ask because you're kind of frustrated. I while you're working on the homework problem. You have two independent sample tests, independent sample tests, right? A dependent sample test. Then the way you organize data is different, okay? But remember this. When you're creating a data set, the set of the data is this. In the data editor, every row, right, is for a subject, okay? Or this is for a, well, you can call it a subject or a city or an year, right? For that year, handgun registration this much, number of people carried is this, and that's from same subject, right? Or same experiment units, okay? So you have to just enter in this way, okay? I hope this makes sense. All right, so I close it, and before I run it, I need to do the graph, scatter plot, plotting. Usually X variable is for the explanatory variable, right? And Y variable is the outcome variable. Situation like this, usually you like to model why so many people got killed, right? So number of people got killed, these are response variable. And handgun registration will be explanatory. And the explanatory usually will use X, and then outcome using Y, right? I'm going to uncheck all these so my graph going to look more clear, right? Let me see. I have a trouble here because I had my resolution too high. I can't go to the OK button. Let me see if I can click enter. Okay, that's good. Okay, so you get a scatter plot, right? So at least you see that. And you can always go back to your code to ask to change X label and Y label, right? By typing comma X lab and comma Y lab equal to actually modify the graph, okay? To modify the label. I think you remember that, right? So that's actually for graphing. You see the clear linear trend, right? So it makes sense to do the correlation. So click statistic, click summary. There's a correlation test. Click on correlation test. You have to pick the two variable. So I just hold control key and select the two. And Pearson product moment is really just the Pearsons correlation test, right? And if you like to have Spearman rank order test, you check this, right? But I just want a Pearson correlation, okay? Let's check that. Two-sided test. You see you can check whether correlation is less than 0 or greater than 0, right? Depends on the version. I think in newer version you have an option tab. You click on option tab, you have all these options, right? I think mine is older version, but I click OK, you get the result. You get a p-value that is 5.109 times 10 to the negative 7 power. That's a pretty small number, okay? Your t-score is this, okay? Here is the confidence interval estimate for the coefficient, correlation coefficient, okay? This is really neat. Years ago, when I tried to find this, it's hard, right? And the software, this is great. Okay, so that's how you do the test for correlation. Very simple, right? You just need to know how to get the data in. Of course, if you want to calculate the Spearman's correlation, you just check the Spearman's rank order and click OK. Then you get the p-value for the Spearman's correlation test, right? Test whether it's equal to 0 or not. You see the setup there, it just allows you to test 0 or not. That means that's usually what people do, right? Okay, good. So that's for correlation. Let's look at the